Have you ever stopped to think about what actually happens when you send a text, stream a movie, or, just grab cash from a machine? What is the invisible force making all of that happen instantly? Well, welcome to Tech and Trends. Today, we're jumping right into this explainer to uncover the invisible web of connections that powers absolutely everything in our modern digital lives. And, let's be honest, it's the exact same thing that gives us minor panic attacks when it suddenly goes down. We are talking about computer networking.
Here's our quick roadmap for today. We'll explore the invisible digital web, define exactly what a network is, track the journey of data, size up different network types, look at real-world benefits, and finally, peek into the future scope of networks. All right, Section 1, the invisible digital web, magic behind the screen. Let's ground this whole concept in reality with something we all do without a second thought. Have you ever wondered what actually happens behind the screen when you slide a piece of plastic into an ATM and it magically just hands you cash? I mean, it feels totally instantaneous, right? But there is actually an incredible journey happening in mere milliseconds.
This brilliant little interaction perfectly illustrates our topic. Your ATM is essentially a highly sensitive computer executing a rapid-fire sequence of network communications. You put your card in, enter your PIN, boom. The ATM sends your encrypted data over a secure network to a transaction processor. That processor routes it to your specific bank for approval. Once the bank is the green light, the message travels all the way back and the dispenser releases your exact cash. That lightning-fast conversation, that's a network in action. Moving on to Section 2. What is a network? Connecting the dots. If we strip down that entire global ATM process, we get down to one core concept. At its absolute most basic level, a computer network is really just a group of computers and devices linked together so they can securely communicate and share resources. Whether it's a massive global banking system or just your laptop, smart TV, and printer at home all sharing a single internet connection, that is a computer network. They are connected, and they are talking to each other. To really help visualize this, let's think about cars on a road. Devices need space to transmit data, and this analogy just perfectly captures how network capacity or bandwidth dictates speed. Think of bandwidth like the width of a highway. Just like a wider highway can fit way more cars at the exact same time, having more network bandwidth means way more data can travel back and forth without causing a massive traffic jam. So the absolutely crucial point here is that this invisible infrastructure enables nearly everything we do in our daily routines. We literally rely on networking when we connect our mobile phones to Wi-Fi, scroll through social media, jump into a multiplayer online game, make a quick video call, or stream our favorite shows on a smart TV. It's the invisible glue holding our entire digital lives together. Okay, Section 3. The journey of data, from A to B. So how does data actually make that journey across these networks? Well, when you send a message or a file, it doesn't just travel as one giant, clunky block. Instead, data is broken down into tiny little chunks called packets. Think of it like writing a really long story, but mailing it out as individual letters through the postal system. Every single device has an IP address, which is basically its house address. And devices called routers act like postal intersections, constantly directing your data packets to prevent traffic jams and make sure they arrive at the right front door. Now, for all these different devices to understand each other, they have to speak the same language, which we call protocols. TCP, or Transmission Control Protocol, is kind of like reliable registered mail. It carefully checks for errors and makes absolutely sure every single piece arrives perfectly. UDP, or User Datagram Protocol, is more like sending a quick postcard. It provides fast, best-effort delivery without waiting around for confirmations. And that is absolutely perfect for things like live video calls or gaming, where a tiny bit of occasional lost data won't completely ruin the whole experience. Section 4. Sizing up network types. From rooms to the world. As we zoom out, we categorize these networks by their massive differences in sheer physical scale. It ranges from turning your phone into a tiny personal hotspot for your laptop, which is known as a PAN or personal area network, to a LAN, which connects devices in your house or your office building. Then we scale way up to a MAN, connecting a whole city or university campus, all the way up to a WAN, which spans entire countries. In fact, the sprawling global internet itself is a WAN. Networks are just sized perfectly for whatever their specific geographic goals are. The contrast here is pretty massive. Your LAN is your fast, private home network. It's got low latency and you completely own and control it. On the flip side, a WAN, like the global internet, has huge reach and connects multiple geographic locations, but it relies on highly complex, extremely expensive public infrastructure to make it all work.
All right, Section 5, Real-World Networking Benefits, Why It Matters. So why does all this invisible digital plumbing actually matter to you or a business? Well, the everyday benefits are enormous. By centralizing data and sharing resources, networks save tons of money. They let an entire busy office share just one single printer, they prevent costly errors by keeping databases centralized, and they give us the power to communicate, work remotely, and learn online seamlessly from literally anywhere on Earth. Let's head to Section 6, Future Scope of Networks. What's next? Let's look forward for a second because the demands on our digital highways are only getting more intense. The future landscape is incredibly exciting. With the massive explosion of AI and cloud computing, we are moving gigantic amounts of data instantly. Maintaining secure, ultra-fast networks to support all of this is creating incredible, high-paying career opportunities in cybersecurity and system administration. Oh, and to keep all this futuristic tech from just descending into total chaos, there's an ultimate rulebook working behind the scenes. It's called the OSI model, and it's made up of exactly 7 layers. It's basically a standardized framework that ensures all these different global devices made by totally different competing companies manage to communicate flawlessly without breaking down. Which leaves us with a final, slightly provocative thought. If every connected device is a door to the world, how secure is your digital house? That brings us to the end of our explainer. Thanks so much for watching Tech and Trends. If you want to keep exploring how to secure your digital world and learn about more amazing tech concepts, be sure to like, share, and subscribe. See you next time.